All right, so section 3.5 is systems of linear equations in two variables. Hopefully you remember the basic ideas behind this from Algebra 1. It's basically where you're going to be given two or more equations and you need to solve them. Okay, so there are three ways to solve. Does anybody know one of the three? Yes, sir. Yes. What'd you say? Substitution is one of them. Anybody know another one? Dennis knows them all. Anybody else? Come on, people. Substitution. What else you got, Dennis? Elimination. Elimination sometimes is called linear combinations. Just so you know, you might see it in the book or somewhere else listed like that. And there's a third one. Yes, sir? Graphing. All right, so those are the three ways or the three options we have for solving two equations. We're going to do one of each in the notes. So example number 1, we're going to use elimination. And here are your two equations. 4x plus 3y equals 5. And 2x minus 5y equals negative 17. Elimination is good and comes in handy when your equations are in standard form. These two are in standard form, where you have the x term first, the y term second, all equal to some number, okay? And the big thing about elimination is you want to look for opposite coefficients. So you study the numbers in front of the x, see if they're opposites. These guys aren't. Study the numbers in front of the y's, see if they're opposites. These guys aren't. And so you're going to either need to multiply one of the equations by something, or sometimes both of the equations by something to get them to be opposites. When they're opposites, they'll eliminate. That's why it's called elimination. Okay? All right, so I'm going to take this first equation and I'm going to multiply it by 5. So 5 times 4x is 20x. 5 times 3y is 15y. And then 5 times 5 is 25. Okay. Then I'm going to take my second equation, and I want to get my y's opposite, so what would I multiply the second equation by? 3. Okay, so 3 times 2x is your 6x. 3 times negative 5y is your negative 15y. And then 3 times negative 17, I have negative 51 down here. Okay? And then this is why it's called elimination. The coefficients on the y's are opposites, and so they eliminate. And you're down to one variable. That's the whole point of the thing, to get down to one variable so you can easily solve for that variable. So you're going to combine the 20x and the 6x to get 26x. You're going to combine the 25 and the negative 51 to get negative 26. Divide both sides by 26. And your x equals negative 1. Once you've solved for one of the variables, you'll just take that number and plug it back into either of the two original equations. Okay? And you can pick either. So like, whichever one looks easier is my rule. And generally there'll be one that looks easier, except for this one, they both kind of look the same. So I'm going to do the first one. Did I do the first one? No, I did the second one, sorry. So I'm going to say 2 times negative 1 minus 5y equals negative 17. And then 2 times negative 1 is negative 2. So we're going to add that 2 to both sides. So negative 5y is negative 15. Then when you divide both sides by negative 5, you get y equals negative divided by negative is positive. So the two answers are x equals 1, negative 1, and y equals positive 3. So when you go to list your answers, you could list these separately as x equals -1 and y equals 3, but the best way to write your answer is as an ordered pair. Okay, so your x value is going to go first, and then your y value is going to go second. Okay? Sometimes when you're doing these, you'll get weird answers. Okay? It's nice and ideal when you get this answer. You've got a value for x, you've got a value for y. But let's say you're halfway through the problem and you get something like 7 equals 7 or 0 equals 0. This means that there are infinite solutions. And if you were to graph it, what would that mean? What kind of graph would that be? Does anybody know? They would be the same line. They would be right on top of each other. Okay, so you'd basically be given two equivalent equations. Okay. Another type of answer that you might see would be -3 equals +6. So instead of getting x equals -3, you get -3 equals 6. Your x's cancel out, and all you have is -3 equals 6. Okay. This one is not infinite solutions. It's what? No solution. What kind of graph do you think that one would be? What? Parallel lines, right? They're never going to intersect. They're never going to touch. They're parallel lines. Okay? So this answer is where your two lines intersect. You've just got that one point. Okay? This answer is the same line. They're right on top of each other. And then this weird answer is parallel lines. They're never going to intersect. Okay? Any questions on that? All right, let's look at it. For example number 2, we're going to do by graphing. And here are two equations. 3x plus 5y equals 15. And x minus y equals 4. Oop, let me move that up. There we go. Okay. Now, if your equations are given to you in slope-intercept form, it's pretty easy. But if they're not given to you in slope-intercept form, you see how I wrote them side by side? That's so I have space underneath them to get the y by itself. Okay? So I have to subtract 3x, which leaves us with 5y equals -3x plus 15. Divide everything by 5. Then we get y equals -3/5 x plus 3. So 5. Okay. Second one's a little bit easier. Subtract the x. Get -y equals -x plus 4. Multiply everything by -1. So we get positive y equals positive x minus 4. So what's the slope going to be on this one right here? 1 over 1. Okay. So if you need to, squeeze it in there, and then let's graph it. I'm going to move it up. You'll see it in just a second. There it is. All right. So you're going to sketch your x and y axis. And if they turn out to be similar to the answer to number 1, like right at a corner, it's going to be a lovely little answer. But the book has some that aren't, that when you go to graph them, they're not going to cross exactly at a corner. And it's going to say something like, estimate the solution. Just know that's coming. All right, so the first one is going to cross the y-axis at positive 3. So up 1, 2, 3, put a point. And then the slope is negative 3/5. So down 1, 2, 3, over 1, 2, 3, 4, 5. So it's this line right here. There's your first line. The second line crosses the y-axis at negative 4. So go down 4, 1, 2, 3, 4, put a point. And then the slope is 1 over 1. So up 1 over 1, up 1 over 1. It looks like it's kind of going straight there, but as you get closer, it's not exactly at a corner. See that? It's kind of right in the middle of a box. Okay, if it's exactly at a corner, perfect. If it's not exactly at a corner, they want you to estimate it. Okay, so this point right here is at 1, 2, 3, 4. What do we call that? Half, 4.5? You guys happy with 4.5? 4.5. That's a good estimate. And then up half. Sure. 4.5, half. Okay? If you're asked to estimate, at least get within, the numbers. Okay? If you want exact, you can use Desmos. It might give you it as a decimal, not a fraction, which is fine. But make sure if you use Desmos that you show the graph on your paper. Okay. And I think it does give it to you as a decimal. All right, let's do a substitution. So example number 3. We're going to use substitution. Substitution is kind of the easiest one, but basically you want to solve one of the equations for one of its variables and then substitute it into the other. So the first equation is y equals 2x plus 7. The second equation is y equals 3x minus 4. And the way these equations are written, I say they're even better for graphing, right? Because they're already in slope-intercept form. But I'm going to show you substitution on them. And you can technically use any of the methods on any of the problems if you just change it to the right form, okay? All right, so the first equation is already solved for y. So I'm going to take everything that y is equal to and substitute it into the other equation where the y is at. So on this problem, it becomes 2x plus 7 equals 3x minus 4. They're essentially equal to each other because they're both equal to y, right? Okay, so we're going to subtract 3x from both sides. I'm going to subtract 7 from both sides in the same step. 2x minus 3x is negative x. These are opposites. These are opposites. Negative 4 minus 7 is negative 11. I need it to be positive, so I'm going to multiply both sides by negative 1. And we get x equals positive 11. And then that 11, you can plug into either of these two original equations. The first one looks slightly easier. So I'm going to say that y equals 2 times 11 plus 7. So that's what, 22, 29? All right, so what, 11 and 29. Any questions on that one? All right. You've now seen one of each. In the Ed Puzzle, there's one more of the elimination. Okay? So if you want to see another elimination, there it is. If you still have any questions once you get started and get into it, let me know. You're welcome.